Well, it is after 5, my good friends, so got a couple open spaces, I think. But it's a little bit after 5, and that's our official starting time, so I'm going to go ahead and call this meeting of the City Commission, the Committee of the Whole meeting, to order for Monday, March 17th, 2025. First order of business is roll call. Clerk Burling.
Commissioner Cooney.
Present.
Commissioner Decker.
Present.
Commissioner Hoffman. Commissioner Pradle. Commissioner Wilson.
Present.
Vice Mayor Hess.
Present.
Mayor Anderson.
Here. Thank you, Clerk Burling. May I have a motion to excuse Commissioner Pradle and Hoffman from this meeting?
So moved.
Motion made by Vice Mayor Hess. Supported by Commissioner Decker. All in favor, please say aye. Aye. Opposed, nay. Motion passes. Communications, Manager Isma.
Nothing, Your Honor.
Thank you so much. Now is the opportunity for public comments at the Committee of the Whole meeting. Just a reminder, public comments are limited to 2 minutes at the Committee of the Whole. You have opportunity to speak on any topic you would like. If you desire to speak, please come forward, state your name and whether you live in the city. Seeing no one, we are now down, Manager Isma, to the work of the evening.
All right, thank you, Mayor. For our work session this evening, we've got our Director of Public Services, James Baker. He's going to be presenting on the Kalamazoo Water Reclamation Plant Sustainable Biosolids Alternative. So I'm going to turn it over to you, Director Baker, and you can give your presentation.
Welcome, Director Baker. Nice to have you here.
All right. Well, thank you. I'll welcome. I want to thank the city manager for giving us this opportunity. Before I get into this is something that we've been in front of the city commission a lot here lately on this topic. The city commission did just award a $12 million design contract for this work that happened in February 3rd of this year, which is not too long ago. And we plan to be back in front of this body again in April. And we've got a public meeting that happens on the 25th. So I'm going to get into that during the presentation, but I just want to kind of highlight that this is a very current topic for us, and there's a lot of information and a lot of opportunity for engagement as we do this work. So just a little bit of a recap. I don't know if everybody was tuned in last time, and I know we've got a lot of folks online that might be just now hearing about this subject, might be picking it up. But biosolids, to give a brief definition of what that is, our treatment plant treats about 27 million gallons a day of wastewater. That water comes in, kind of everything's mixed up together like a soup. We clean up that water and we discharge clean water via permit to the Kalamazoo River. That water that we discharge to the Kalamazoo River is actually cleaner than the river itself. We then have a byproduct that is a biosolid residual that then goes through a different process. That other process, that side stream process, is that biosolids process that we're talking about here. Kalamazoo biosolids are not suitable for what we call land applications, so we don't go out and apply those on the fields. We have done that in the past. There was a brief period in the early 2000s where we went out and put some product on some fields. We've since kind of gone away from that process. All the sludge, all the biosolids currently goes out to the landfill. And landfill costs have increased dramatically over the last several years. If we go back to 2019, we were paying around $4.5 million a year. We're up to $13.5 million a year now, and those are operational dollars. Those are part of rates. That's 1-for-1 with rates as an operational dollar. So of the dollars that we collect every year from your water bill, $13.5 million goes to take sludge to the landfill. And if we compare not too long ago, 2019, we were at $4.5 million. So this is really something that we've been very tuned into for the last several years. We started in 2023 issuing an RFI. We had over 30 different technologies that responded to that. So that's 30 individual different technologies that we had to go through and evaluate to kind of really zero in what technology we were going to pursue. So we had a stakeholder conference back in November of 2023, really kind of looking at those 30 alternatives and trying to kind of break those down and narrow the field, looking mainly at greenhouse gas emissions, potential for odor generation, and worker safety. That then gave us a smaller list, smaller than 30, but still a lot to work through. We then met again about a year later. We sent the engineers back to do some homework, and we came together back again in November of 2024. And this time we had a smaller group of technologies, but we dove a little bit deeper into costs, life cycle costs, not just the purchase upfront cost, but the overall cost of that technology over the life cycle. Greenhouse gas emissions, we went a further dive into this. Odor generation, again, a more detailed dive into that. And then PFAS destruction. So knowing that PFAS is something that's a contaminant that we have to deal with now. It's regulated. It's regulated both in drinking water and it's regulated in wastewater as well. It's also regulated in the sludge that we take to the landfill. So this is just some breakdowns relative. These are relative costs, annualized costs broken out to make the technologies comparable so you can see them. The orange bar on top is the capital cost converted into annualized dollar cents, and then the blue is the operational. So if you see where we currently sit, the process that we are doing now is the most expensive option. The no action is the most expensive. In terms of odor potential, we didn't put a chart on here, but I talked about this at our last meeting. I said if we had to put an indicator under our current odor potential, we'd probably be in the yellow for what we're doing right now. What we have proposed is the dryer and ERS. You see that needle is in the green. In terms of carbon footprint, this is the total carbon footprint from taking our material that we have right now, putting it into semi-trucks, hauling it to landfill, and then it actually continues to decompose in the landfill. The process that we selected and that we are moving forward with is the dryer and ERS. Destruction and contaminants an emerging concern, mainly PFAS. We're also talking about some other things here as well. Those are going to be, other contaminants that are inherent to that waste stream. 60 to 70% of our load at the Kalamazoo Water Reclamation Plant is from industrial sources. So certainly PFAS is what we're talking about today, but we're going to be talking about something else in the future. That stakeholder group overwhelmingly supported that concept of dryer and ERS. We had two members of the stakeholder group. You can kind of see there's a photo of their index cards where they voted. Two members voted for just a dryer. With the dryers, just the dryer technology doesn't address. It doesn't address the PFAS contamination issue that we could be volatilizing into the air, and it also doesn't address odors. It doesn't fully address odors because the process is kind of incomplete. It takes and dries the material, and then we're kind of left with a dry material at that point. So we've taken a lot of action. Well, one of the things we want to highlight is that we've now published our Clean Water State Revolving Loan Fund application, what we call our project plan. So this project plan is published. This is an announcement that's gone out. You can use that QR code to get to our project plan webpage. We've got a description of the project plan. The project plan itself is about 296 pages, not including the appendices. If you add those in, it's over 800 pages. So it's a very thick document. A little challenging to get through. Some things, if you go through that document, some things you're going to see. We're looking at placing this project. We've got kind of two sites narrowed down. So we've got our 1415 Harrison site. We also have 600 East Mazel. 600 East Mazel is kind of north of the salt barns at our Harrison site. So what does that do? It gives us the ability to be a little bit further away from the populated areas in our neighbors in and around our north side neighborhood. So that is something that we are looking at, that's identified in the project plan, kind of moving that footprint to the north. You also see some cost estimates in there. Our current best estimate for cost for this project, all in, is $194 million. That's a little bit higher than where some of our previous estimates were. Some of our previous estimates were around the $150 million range, so this takes it up a notch. That does start to impact payback period. So you heard me at our last meeting when I talked about payback period, my response was about 10 years. At 194 million, we're moving that closer to 18 to 20 years. There is uncertainty with that, and a lot of that deals with what are we paying per ton to get rid of this sludge. If you would have asked me in 2019, when we were paying $4.5 million, that's a whole different payback period from now, where we're paying over $13.5 million. So as that sludge costs increase, it's hard to kind of keep that payback period fixed, so that it's a variable rate on that sludge what's going out. So we're going to continue to refine those numbers. That's something we're going to be talking about in the public hearing. We're going to talk about the project cost, that $194 million for this project, $2 million for a project that is going to be in the Kleinstuck Marsh for a sewer project that's going to help to prolong some asset life that's out there. There's a 1929 sewer that runs through Kleinstock, beautiful nature preserve. We'd like to do our best to keep that sewer in good shape, so we're seeking some funding for that. And we've got another sewer downtown that needs some work. So that all together goes for that project plan. So we're going to talk about that in that public hearing. There's some specific responses that we have to do in terms of cost per REU. An REU is a residential equivalent unit. So a typical household is a REU. A industry might be 200 REUs. So the cost for a typical household for $196 million of improvements is about $12 a month. So that's a lot of money for residents. We understand that. That's why we're seeking this funding opportunity. So rates are a concern for us. Certainly, that is. $12 a month for a resident is a lot for us. That's not a rate recommendation. That's not a rate number. That is a number that we have to supply with the funding application. It doesn't mean that your rates are going up $12 a month. It means that if we only looked at this project, kind of with our blinders on all other things, that project would cost a typical household about $12 per month. Also wanted to highlight on our project page, we have a video. Mike Smith put together this great video for us. It's on Public Media Network. It's about 20 minutes long, and we go through kind of the current sludge process at the Kalamazoo Water Reclamation Plant. We also have some samples on the table. We provide some visual demonstration of what this product could look like in the future when we implement that future process. And we do show the cake. You can see the cake as it's stacked in the bins, and you can see for yourself it's certainly a pretty unpleasant process, and it's a pretty unpleasant process to just have, you know, right here in our community. So we're really looking to do something better into the future. So some specific timelines: March 25th, 6 p.m., Mount Zion. We've got our public hearing. We'll be back in front of the City Commission on April 21st. We're going to request City Commission approval of a resolution to adopt that project plan. That will then give us the ability on April 30th to submit that to EAGLE, which is our funding application. We'll understand the results of that funding application in September. So we'll know, can I go, no go for the project? What kind of funding did we get? You know, what kind of other benefits around the funding in terms of, you know, term and loan rate, that kind of thing. We'll understand that. We then will have to go after 2 different sets of permits. We've got wastewater construction permits. Those are our Part 41 permits. We also have air permit to install. That air permit to install permit that has its own process for public hearing. And so during that process, we'll have more exact information on, what kind of parameters this new technology will have in terms of treatability and improvements for air quality overall. Construction timeline, if everything moves through, we're looking at 2026 through 2030, and then operational sometime around that. If you really want to focus on, again, some milestones here, just kind of walking through some major milestones. These are high level. If we start kind of at the top, upper left, you see in 2019, $4.5 million per year sludge disposal. You get through everything row by row by row, you get all the way down to the bottom, middle of the page, 2030, dewatered, dried, oxidized mineral ash disposal, less than $2 million per year. So how do we get there? We get there through a lot of engagement as a community and a lot of focus still as a community to improve our biosolids process to something sustainable into the future, not just the cheapest thing to do today, which might end up costing us a lot of money in the long run. And with that, we'll turn it back over to the commission for any discussion.
Thank you very much. I can't tell you how important I feel that it is. This is not only a huge investment, but an opportunity to make a transformational change for us in how we manage this 26 million gallons and probably increasing over time that comes through our wastewater plant. So I just don't think we can repeat ourselves often enough, and I appreciate all the opportunities to look at this, for you coming back too. So thank you for that. Questions, Commission? I'm sorry, Manager Ritzman.
Thank you. Just a couple of questions come to mind. So on the chart that shows the cost, so the recommendation is the dryer and ERS, and then there's no action, which is significantly higher. So you said the 150 when it became like 192 million-ish. Are all the other options equally as more expensive? So
Yes, thank you, City Manager. This technology isn't seeing cost increases in a vacuum. And to put that in perspective, the steel, we know a lot of processes and things we buy and have to acquire are made by steel. Nucor, which is a manufacturer, one of the biggest manufacturers of steel that meets the American steel or buy America, buy American, have raised their prices 5 times since January 20th. So we see that a lot of industries, heavy industries, manufacturers of steel, things of these big raw material inputs to processes and projects are seeing some, rather dramatic cost increases, right now, in the near term. Some of that is also just due to our better refinement in equipment sizing. So we know that we have to size for ourselves and be redundant in that sizing, so that, when we put in dryers, we know to make sure we got enough dryers to work when one goes down, and we can still, kind of carry our full capacity with that point. Some other treatment plants or municipalities may not choose to be redundant in their processes. They might just say, hey, if something goes down, we're just gonna, do what we did before and then fix it. So there's been some smaller incremental costs in that. But I would say, looking at these technologies, the dryer, the fluidized bed incinerator, the supercritical water oxidation, and the dryer and gasifier are all experiencing, cost increases. That supercritical water oxidation process doesn't exist yet on a municipal scale in the United States.
Okay.
So that's also something to consider.
So as far as the no action goes, that's continuing to landfill our biosolids. So that's just going to continue to go up. Do you see a point where we'll no longer be able to landfill, like they'll shut us out completely?
Right now, we're not seeing that in Michigan. A lot of that just deals with regulations, but with biosolids. We saw that in Maine and Connecticut. So both in the states of Maine and state of Connecticut, you cannot take biosolids to the agricultural fields. That's not the case in Michigan yet. Michigan still is as a state, a proponent of land application. So we're not seeing that from the industry, but we are seeing increased competition for landfills. Landfill space is at a premium. This material, outside of the chemical components of it, just the material itself is not a good material for landfills. It behaves like a clay. It's squishy. It's not stable. It's not a structural material. And landfills are all about building up, and so it's been a problem. We have been talking to Waste Management. We continue to talk to Waste Management. They've been great to work with. They're going to support us through this project, and we're going to develop a long-term, model going forward that could be bid and competitively bid by other landfills if they so choose as well. And we're seeing that they're likely going to take action on their end to make sure that they can continue to take sludge, which means that they may also be investing in a dryer so that they could continue to take sludge as well.
Thank you, Manager Ritzman. Commissioner Pradel?
Thanks, Director Baker. A couple of these questions I might have asked before, but I figure I might as well encapsulate them in this presentation so that if people want to watch this later or we want to share this with other people. So one of them, could you remind us again about the tonnage per day, what we're seeing taken, carted off in trucks versus like the tonnage that would be taken once this technology is implemented?
Right. So right now it's about 200 tons a day of dewatered solids that are about 23% solid. So it's mainly water. To visualize that, it's about 20 full-size the big city wing blade plow trucks that are tandem axle, so they've got two wheels in the back. Would need about 20 of those a day to haul this material out.
Wow.
At that point, once we've dried everything out, we're talking less than 2 trucks a day.
Yeah, it's pretty wild. It really puts into perspective too, when you're talking about just one day, multiplying that by an entire year worth of sludge removal.
Yeah, and I would really encourage folks to take a look at the link that we provided for Public Media Network, that video that Mike put together. Within that video, we've got samples of what that dry mineral ash looks like, and you see the cake both in real life in the video, and you see a small sample of it as well. We don't have smell vision or Public Media Network doesn't yet, but I'll tell you, the folks that were in the room that experienced that when we just took the cap off that cake material that we haul right now, that we treat, process, manage, store, and haul that wet material, it's got a very strong odor signature to it. When we were opening the jars of the dried material and then of the oxidized mineral ash, that's 2 different products, there's no odor at all. There's really nothing there. And that is really that's the big change that we're going to have at the community level, is that we get away from the processing, managing, storing, transporting the wet material, and we move over to this dry material. And that dry material is essentially all the way through the end of the process, it's a dry mineral ash.
Not to mention 18 less trucks, puffing diesel through our neighborhoods
Certainly.
Per day as well. The other thing I was curious if you could share a little bit about is you mentioned there's one example up there where it's not been done, it's not been tested, and that there are risks involved with that, right? I mean, to spend that kind of money on something that hasn't been tried before. In terms of the dryer, dryer and ERS technology that we're looking to use, are there examples around the country that are using this? Long-term examples that we can look to maybe learn from? It's a lot of money to spend on something, and I think it would be really reassuring for, at least for me, I feel like, to make a decision, but also, for the community to feel like this is something worth investing in if they know that it'd be a reliable solution.
Sure. So, kind of looking at these technologies in front of us is a, good time not only to talk about the technology that we're proposing, but some of these other technologies as well. There's two parts to this. There's the dryer, and you can see some more detail in the published project plan goes in and provides some photos and some detail on what that looks like. That process has been around for about 40 years now. Really refined to where it's at today, probably within the last 25, and then, really, just advanced probably within the last 15. The ERS has been around in European countries since 1995. So that's about 30 years of, real strong support and use, like, in process, not just in lab or in theory, but actually in process, in municipal use in Europe for the last 30 years. It's been in America, we've got one installation in America that's been in service since around 2012. And then we've got a project right now that's, sorry about that. So we got a project right now going up in Warren, Michigan, which is going to be about half the size, about half the footprint of what Kalamazoo is. And that project, that's going to be a regional project. So that's not just Warren, but it's also Wyandotte as well. That's going to be kind of coming together on that project. So when our project is operational by 2030, there'll be 3 installations in the United States on this. To compare that to fluidized bed incinerator, fluidized bed incinerator has been a technology that's been around since the 80s, and they've got hundreds of installations across America. There's also, it's not on here, but a multiple hearth incinerator, and that's been technology that's been around since the 30s. And again, thousands of those, across United States. The process, the ERS, is not an incinerator by definition. It doesn't use the natural gas to combust and make heat. It uses the carbon in the process to combust and make heat. It's also much cleaner. It burns at much higher temperatures. So from an incinerator standpoint, if you just say incinerator, we're talking about 14 to 1600 degrees. Our ERS is projected to operate between 1800 and 2200 degrees. So it's intentionally designed and built at a whole different scale from something else. And we'll get more into the technology aspect of it as we talk at our future public hearings, future public meetings as we know more about it. Supercritical water oxidation. That's a process that's, really high speed. There's a lot of science and technology involved in that. But even that doesn't exist yet on a municipal level.
Okay. I just have 2 more questions for you. So one of them is you mentioned that the payoff that you are envisioning for that $194 million now is kind of revised to between 18 to 20 years. If you do the math with $15 million per year, let's say that the sludge removal doesn't increase at all, which it's bound to do, that's $270 million that we would be just effectively throwing away compared to a $194 million strategy. And granted, there's still going to be 2 trucks per day that are taking away sludge, so there's still a cost with that. My question is technology is advancing quickly all the time, and 18 to 20 years is a long time. So, the technology that we're paying off, what's the longevity or the shelf life for the technology that you foresee that general maintenance, repairs, those kind of things that could be costs that could increase that payoff time as well?
Yeah, certainly. So from a technology standpoint, we're really focusing our build quality, specifications, redundancy, and overall process durability, kind of our process lifecycle durability of the dryer and ERS for a 40-year design life.
Okay.
So that's what we're focusing on. We really understand that there's kind of a lot of unknowns in the first 20 years of this project life cycle in terms of are we outpacing the would-be sludge disposal costs? Has those technologies, which is kind of the do-nothing technology, has that ran out, or is that going to continue to be really costly? Is there some other technology coming to the market, or not. So we wanted to kind of extend that life cycle out to make sure that this project's going to continue to serve the city positively into the future, you know, in a well meaningful way. And a lot of that really is focusing on, you know, what do you put a cost to the smell of odor generation in a neighborhood? And, you know, even if we find out that, okay, well, the landfill costs have stabilized or maybe even gone down, and now we're paying the capital costs and the maintenance costs, and so maybe they are a little bit more equal than we thought going in. But, you know, our future vision on this is really kind of predicated in the fact that we went from $4.5 million in 2019 to $13.5 million where we stand today. And I remember coming up here in front of this commission and asking not only to approve the contract, but to make a budget amendment to approve the contract. Because in those first steps, we went from like $4.5 million to $9 million. And if you remember, we also had a 20% rate increase in 2023 because costs, mainly this sludge cost, but there's some other costs in there too, were literally doubling between rate periods, and we couldn't keep track with that. So there certainly, and I'm going to acknowledge there is some uncertainty in payback period, but I also want to highlight, you know, what our vision's been to get us here, and then what we're planning for the future, so that, you know, regardless if we're wrong or right on payback period, we're going to be right on our impact to our community and our neighborhood.
Either way, it's $270 million versus $194 million estimate, so that's a pretty wide gap there. The other thing too, I know you and your team have put a lot of thought into the work and the capital improvements that we do related to like redundancies and making sure that there's like contingencies if technology like were to fail or something were to go out. What kind of things are baked into this, if you will, to make sure that there are, you know, backups in case, you know, something fails or whatnot? I mean, does it just kind of return to like temporarily until it's fixed, where there would be like truck-loaded sludge removal for a period, or what does that look like in case?
No, this is a great question, and this is something that we've been working on for really diving into this for the last, I'd say about 6 weeks, with some really difficult challenges and kind of forks in the road to make those decisions. So we want to make sure that this is a reliable process and it's a redundant process, so it's going to work, you know, kind of no matter what. So we kind of built out, the first step in that is understanding what is our need. Is it 200 tons a day? Is it 203 tons a day? Can we get by with 196 tons a day? So we literally plotted every single day's solids production over the last 10 and 15 years. This big scatter plot, kind of bell curve with a lot of exceptions going through. And we've gone through and normalized that and scrubbed the data and refined the data to make sure that we're really looking at our accurate numbers. So that was kind of the first step, is to understand what our need is, and then putting some future casts on that so that we're able to continue to grow as a region. That's always been, you know, one of our goals. We've served 22 municipal customers, not just the city of Kalamazoo, but there's a lot of room for growth in all that customer base, so we want to make sure we project that correctly. But we don't want to oversell it, because that's going to cost, you know, the dollars in the project. So we came out with a number that's going to fit us. We divided that number out into units, so we got kind of a plan on paper for 5 dryer units. And then we've been in conversations with the manufacturer on, would it be better to have 2 ERS or 1 ERS, 2 big ERS or one big ERS. And so what we're hearing from the manufacturer at this time, and there's some more refinement that has to go into this, so this could change, or this is our assumption going in, is that it is more cost effective to build 1 big ERS as opposed to 2 small ERS. And so equaling the same number of output. The other challenge is that we've got to make sure that we have APC, air pollution controls, for everything that goes through the dryers and through the ERS system. And that if the dryers are down or the ERS is down, we still can go through APC. So we've been kind of proofing that all out, talking to the manufacturer, making sure you know, we're doing the right thing and our assumptions are correct. And so that's kind of what we've got built out. It would be a bunch of redundancy in dryers, and then inline capacity with dry bulk storage. So once it goes through the dryer, we're at 75% dry. And we've got some, jars that show that in the video series that shows that. At 75% dry, we can go through a crusher and crush that and have a crushed dry product. We can blow that into bins, think of like silos, grain silos, if you will. Dry inert material can be stored on site and not present an odor challenge or an odor issue for the community. That will give us the ability to shut the ERS down, perform maintenance, get it back up and running again, and then, load out from those, from that dry bulk storage. Another concept that we're working on, and we've had a lot of great support from Waste Management, is that we're going to be meeting probably within the next 30 to 60 days to kind of lay out what a future contract schedule would look like. And what we're talking about would be 10 months of oxidized mineral ash disposal, 1 month of dry crushed material disposal, and if worst case scenario, 1 month of dewatered cake disposal, so that we would have kind of every outlet covered, no matter what equipment was up and running. But the main source of reliability and redundancy is going to be utilization of the 5 ERS to always be able to go and get it 75% dry, crush it, and then put it into dry bulk storage.
Glad there are people like your team that are thinking through all these challenging scenarios, but yeah.
Several weeks of this stuff and several what ifs and going back to the manufacturer and, can you build this? What's cheap? Is it more cost effective to build this or that? And so we've been going through all those iterations. There are iterations at this point. If it does come back to, hey, you can do that, but we're taxing the APC too heavily. If we don't have an ERS, then we'll shift and make it. The overall goal is to have the most reliable process and most resilient process from beginning to end.
Yeah. Thank you.
Thank you.
Thank you, Commissioner Praedel. Commissioner Cooney?
Are you expecting that we could get some grants to help with this?
Sure, that's a great question. So this funding application that we're submitting to CWSRF, Clean Water State Revolving Loan Fund, this is kind of the clearinghouse for all state-related water grants, as well as any kind of federal pass-through for water grants. We're also, with our project team, working on submitting a letter of intent for WIFIA, which is Water Infrastructure Finance Act, through the federal government. So we're kind of, with this action, we're kind of, launching or will be launching kind of 2 funding requests. We're also working, within the city team and grant specialists, we put together a funding request for congressional directed spending. That package is getting worked on right now and will be sent to Senator Gary Peters for requests to get some, federal dollars plugged into Kalamazoo. So those are all opportunities. We're asking everywhere that we can. And, we're hopeful that if we're successful in getting some of those funding opportunities, and sometimes it's the funding instrument which could help. If this project was able to get a 40-year low-interest loan, that would really benefit ratepayers and help pay for the technology over the life of the technology instead of paying for it over 20 years. So there's a whole lot of what-ifs still kind of out there, everything from nothing all the way to grants and other kind of lending instruments that would benefit the project.
Other questions, Commissioners? Vice Mayor Hess?
Director Baker, I just love that we're being once again proactive and creating transformational change here. And I really appreciate your and your team's thoughtful process and your vision and really looking into this intentionally. Is there anywhere on our website, and I'm sorry I don't know this, is there a virtual tour of the KWRP anywhere that people could go and see the magnitude of this? Because honestly, having toured it 2 weeks ago, blown away. I mean, I toured it 5 years ago, but then the changes we've made since then, which have also been transformational, are simply amazing. So is there any way that people could tune in and see this?
Great question. I don't think we have that available yet. That's something that we probably need to really think about and consider. Yeah, I'm sure if you went through just recently, you saw our $26 million investment in tertiary treatment.
I did.
And hopefully you're able to look into the kind of the outfall structure, and it's an orange tank. They painted it. It was a blue tank. It's orange now, and you can literally see almost all the way to the bottom of that tank. It's beautiful how clear, crystal clear, this water is going into the river. And if you haven't seen it yourself, come on out. Our next best opportunity for that is Public Services Week, which is going to be the third week in May, which is going to come up really quick. So we'll have information out for that. And everybody from the public can come to the wastewater treatment plant. We tour the plant. And there are new things along the way in the treatment plant. All this, recommendations for projects and all these contracts the city commission's been awarding are really turning into something up there at that treatment plant. It's really quite a beautiful site.
It is. I would encourage everybody to, drone technology, do we have drone technology here at the city, Jim, with Neil and his drones? Just do a flyover and talk to the people that work there. It's fascinating. So a few questions. Will this help us eliminate PFAS and microplastics in the biosolids without affecting your quality?
Yes and yes. So again, great questions. Microplastics is a little bit of a emerging issue. It's not kind of mainstream everywhere. A lot of folks don't know about it yet. We're doing research at our treatment plant with Western Michigan University. We're also doing research with EPA on both topics, on both microplastics and PFAS. This technology, the dryer and ERS, eliminates both of those and does so without any, increase in emissions in our community. The details on that emissions, we really got to wait till we do that work in that design. We've got 2 experts that are coming in. We've got an expert from a PhD professor from University of Dayton that's going to come onto our team to really help us study and quantify what design and APC we need, air pollution controls, that we need to make sure that we're exceeding any local air standards so that this air coming out is not going to impact our neighborhoods.
Awesome. So PFAS, which is forever chemicals, we're going to make them go away.
We're going to make them go away. And that also provides an opportunity for some regional partnership. That provides opportunity for Kalamazoo to provide a potential outlet for some sites or some need within our localized area that would have to get rid of such a material.
Awesome, thank you. Also, do you, is there a beneficial reuse for the product anywhere? You talk about having it in the silos, the crushed ash in the silos, and then besides taking that away, we can't reuse that. Can we reuse that?
I don't fully know that answer yet. I know that there, in the past, similar materials have seen, additional reuse fate that has helped, sustainability. There's been similar products used to help increase concrete density. There's been other use of beneficial fill type material. We haven't fully certified those concepts yet. We don't fully understand what that looks like, and we don't understand the market yet on that. So even if we could, we don't have an answer, today for, we can't tell you, yes, it's going to go into concrete. We don't know that yet.
That's just awesome to think about, that our sludge becomes our roads. I love that.
It'd be a cool concept.
It is. So, as we build a new facility and increase our capacity at the plant, is there adequate staffing for all of that?
Sure, that's a great question. Staffing will have to increase for this project. That's something these cost reflections take that into consideration. So that would be an operational cost. That's kind of a blue box costs that would have to go into that. That's something that we don't have that fully built out yet. But as that process comes online, we're going to start building that out. We're already starting to build that out to understand, where the staff going to report, how do the staff work on it. Our staff have actually gone out. We flew them out to the other site. We flew operators out there. We flew mechanics out there. They got to talk to operators and mechanics who run this process right now. So this is something that we've got support and buy-in from our staff at the actual level where they're going to be putting that work on. So we'll be bringing that forward, and that will likely come probably in budget year 2030 or budget year 2031 as we get the process online. And that'll go through our same process. Essentially, we give that information to our rate consultant. The rate consultant then kind of crunches the numbers in terms of the rate impact of the employees. We take that usually like to the utility policy committee, and then we bring all that information back to the city manager to have kind of a go, no-go test of should that go in the budget or not. And then, if that makes sense and is supported, we put that in the budget moving forward.
Cool, thank you so much. And a big shout out to Susie Dressed on your team and her team of folks that helped tour me through the plant. They were stellar, they were very knowledgeable, and they love wastewater.
It's a great group.
Thank you, Vice Mayor Hess. Commissioners, other questions at this time for Director Baker? Appreciate that. Thank you so much. I have one real quick question here is, do you know the number of residential households that we serve with wastewater services?
From a population standpoint, we're in the 200,000 range, and that number can kind of swell up or fade down depending on how you're counting households and whether you count the transient. We got about 15,000 person transient population at Western Michigan University. Do they count as one? Because 1 meter, or are they 15,000 students?
So say 200,000 individuals.
200,000 individual persons, about that, yeah.
The other piece I was actually, have heard before, but continue to be surprised about, is the large percentage that's industrial sources as well, relative to all this. I mean, is this something that's unique, or is this a kind of a standard percentage across wastewater treatment? And does that allow for there to be industrial activity here that otherwise would not be here in the Kalamazoo area?
Yes, it's certainly, that's a great observation, Your Honor. In fact, Kalamazoo is very unique in that our percentage of industrial waste stream or load compared to our residential, we're really kind of inverted. We serve mainly industrial. We're almost like an industrial plant that also has some residents that we serve. Interesting concept, kind of hard to wrap your head around, but I just came back from the biosolids conference that was in Traverse City, and I sat with some contractors who haul sludge for the city of Toledo. And the city of Toledo produced 70,000 wet tons last year, and our design number for this project's 106,000 wet tons. So we, from a tonnage standpoint, we produce more sludge than the city of Toledo. And we see that along with kind of all the work we do in comparison to other treatment plants and everything else. In fact, Mr. Foster, our rate consultant, when we were looking through numbers, he actually had to stop us and go, wait a minute, send me that data again, because it looks just so inverse in terms of our customer base. So, we really have some very large customers. If you look at just 2 of our industrial customers, nearly 25% of our revenue and loading is wrapped up in just 2 customers. And, we have about 65 industrial customers. So it's not just those 2, And Kalamazoo is kind of a unique area for manufacturing. We've got some, really unique manufacturing in and around this area, which Kalamazoo always has had that, dating back, all the way into the early existence of the treatment plant. That's always been a consideration.
Interesting. Appreciate that. Anything else, Commission? All right, once again, we set? All right. All right. Thank you so much, Manager Wisma.
All right, that concludes our work session. Thanks, Director Baker.
Thank you for spending time on this, and I know this is by no means the last time we're going to be talking about this. Commissioners, now is the opportunity for commissioner comments. Just a reminder of anyone who's watching is that there is also a commissioner comment opportunity that occurs at our business meeting. That's generally speaking when commissioners choose to make their comments. But for a committee of whole, any comments, commissioners, at this time? All right, seeing none, we're adjourned, and our business meeting starts in a little over an hour, right back in the same chambers.